Hello again everyone, it's Sean from Having Fun Repairs and welcome back to the channel. What we have on our bench today came all the way from a customer out in Burlington, Iowa. This is an old school or vintage car amplifier and made in around 1992 to 1996. This Phoenix Gold MS Series 2125 amplifier had a rating of about, 4 ohm stereo at 12 volts. That gave you 125 watts at 2 channels. At 13.8 volts, so you're looking at 160 watts times 2 channels. You could do 4 ohm mono, 13.8 volts was about 510 watts. And then depending on where you research and what you looked into, even though it wasn't, I think, technically rated for 2 ohm mono, you could drive it 2 ohm mono at somewhere around 1100 to 1250 watts. But I think this originally sold around $820 back in the day. And yes, I unashamedly state vintage for 1990s car amplifiers. I mean, if you look at it, a lot of the stuff was gold plated. It was meant to be designed to be put on display. I mean, just look at how it's laid out. This is as far as car amplifier systems go. And for those of you who have qualms with that vintage little thing that I say, a lot of things old are new again. And you can find these being sold on eBay for around $1,500. So you can take that for what it's worth. I mean, we're talking about 30 plus year old car amplifier at this point. So for those of you who are 80s babies who are already 40 or turning 40 this year like myself, or will be turning 40 over the next couple of years, just kind of sit back and think about how that tastes for a little bit. But yeah, everything old is new again, and the customer said that this was actually a working amplifier. He's ran it for many years, and he's wanting to get a little bit of work done to it before putting it, I think, into an arcade or pinball machine or something like that. I believe these things are still kind of sought after. So you'd have 2 copper bars running through here that would carry in your mains DC from the battery, remote connect. He sent this in without the chassis. We're just going to take a little bit of work looking at this. And speaking of like vintage equipment and stuff like that, I mean, if you really get into a lot of vintage electronics, especially like old home stereo receivers, I mean, look up some of this stuff like the realistic STA 2000 or the Marantz 2600 or the Sensui G 33000, or even like a Macintosh 1900. You're talking about from like what, I don't know, 60s, 70s type stereo receivers. Man, those things still sell for a premium. The Sensui G, I think I saw a few for over like 20 or 30 grand on eBay. If you depend on where you look online, you can see that they've been selling for about $7,000, give or take a grand or two north or south. But those things, obviously, they're like the holy grail of vintage electronics, stereo systems. And I realize I'm doing kind of a apples to orange comparison here. But, a lot of these, 90s old school car amplifiers are still highly sought after. And you think about it, they were built to last even in the 90s. And this one has obviously lasted for some time now. But, that's kind of enough of an overview of this equipment. I want to show you real quick the things that we are going to address on this and resolve for the customer, and then we'll get busy. So the individual was smart enough to realize that, he's going to have to replace several of these insulating pads between you don't want that metal chassis backing touching the actual heat sinks, otherwise you're going to short these out. You need those insulating pads, and quite a few of them are missing. And one was actually in a box, as well as some screws and some standoffs. So you'll need to make sure that all the standoffs are back on as well. But the first reason he reached out is because he did notice when taking this apart that there was a burn mark on here. We could see that right there. Yes, fairly observable. I mean, there's nothing really hiding that right there. We're going to address this. Now again, he said it worked. To me, this looks like something. If you were to follow it over, something took a trail through here, maybe some water or something, and then eventually settled here, or something metal, and burned off. But we could see corrosion leading all the way through here. So hopefully it wasn't water, but definitely something conductive. We're going to address that. We're going to, you know, there supposedly is no breaks in the vias or the traces that you have here, but we're going to get out all this carbon, clean this up, and then if we have to do any repair work from cleaning, we're going to make sure that we repair it, and then we get a proper coating over top of it, so that way nothing will short out to, you know, the jumper wires we'll put in or whatever to repair these traces. Now he also understands, having read multiple forums on these amplifiers, that these old electrolytic capacitors need to go. You have several Panasonic capacitors that what would have been in here to begin with that you know, they've become leaky over time. As a matter of fact, we're definitely going to address these 2200 microfarad 16 volt caps that are sitting right here. If you were to look down in the center, and yes, I know I got a light shining down in there, you can see that they've definitely already been leaky. So those are going to come out. We're going to do a bit of cleanup. We're going to get all those replaced. They're peeing on the board. They're old. They need to come out. Leaky caps. We may or may not replace these 10,000 microfarad 40 volt caps sitting here. We'll test them at least. I think these are terminal type. Screw terminal type. No, they're actually soldered in. That's interesting. That shouldn't be too hard. Those shouldn't be too hard to take out either. And then what are these? These might be old Panasonics as well. I'm not too sure. But it's primarily in our audio power section. Audio section going this way. We'll take a few of these out. If I see any leaking, they will definitely get replaced. That one right there actually looks like it's bulged or been replaced once before. That's definitely bulged. That's going to have to come out. Oh, that one's pretty iffy. We'll I'll run a test on these, and if any of them are out of tolerance, we'll replace them. Look, I'm not looking to break the bank per se, right? The individual's planning on keeping this, like I mentioned. You know, he's not looking to get rid of it. When we talked via email, he also indicated that he could tell that I'm not, with the questions I'm asking, you know, is the juice worth the squeeze kind of thing, was as far as he wants to go with work on this. He told me to use my best judgment. He's seen my videos. He sees how I work and how methodical I am with thinking through things. So I really appreciate that. Again, we're not looking to break the bank or anything. We're just looking to give this a once over service, and then if things are out of tolerance, we're definitely going to get those components replaced. I think I see on the other side of where this was burned was right in here. You can see that you have a tad bit discoloration. Again, we got to get rid of all that carbon, because even that can pass electrical current, so that's got to go. We see where the solder is kind of, from that heat on the other side of the board, it's kind of turned into a ball and pushed itself out. It's what you would hear some guys who work on cell phones talk about ball squeeges. I don't know how to say that properly, but yeah, that's all going to have to get addressed. Hopefully none of these components over here with what burned up are bad. We'll have to definitely test those and focus on them a tad bit. But I want to make sure that if we're replacing anything, that it still looks factory. You know, sometimes it's hard to get some things. You know, 22J capacitor right here. What is this? 2.2 nanofarad or 2200 picofarad. Probably 50 volt cap sitting here, somewhere around there. You might be able to get one in like a blue or yellow or something like that. Might not find one in a brown, but we'll do some research, because if it sticks out, you know, that kind of just takes away from the overall aesthetic of how it originally looked. So we'll definitely be very conservative with what we're replacing, and we'll do our due diligence. I'll do my due diligence here to make sure that we keep this looking as original as possible. All right, so to address this carbon buildup, what I'm going to do is use a Dremel and just in a wire brush to kind of first remove a lot of that carbon and then work from there. I know a lot of people probably have qualms with using something like a Dremel tool. No, I'm zoomed all the way in. To remove that when they got you know, tools that are a lot smaller and turn at a less rotation speed, slower rotation speed for doing that type of work. But you know, I've been using a Dremel for years. I know how much pressure to put down. I know how hard to apply, when to remove, and I know how to have a light touch and do this kind of work. So that's not going to be an issue for me. We're just going to take our time and work as carefully as possible and service this thing as best as possible and get this taken care of. Dremel just cleaned up very well all the way across the board, and you know, taking a look at the damage that's down in here, it's honestly not too bad. Okay, so we can see this via here. If you look above, that would be this one right here. That's still intact. The board underneath is obviously a tad bit burned, but we were able to clean out most of that carbon, what was left in here. The main thing is you can see we're missing a via or trace right here. What would be this one right here? That's I believe that one is going, if we flip this over, to that cap right there. So we're going to remove that. We're going to test that cap. We're going to test these resistors here on both sides as well, just to ensure that we've got good continuity between everything. Let me get this pulled out and we'll take a look at them. All of those components removed, we can now test them. What did I do with my pliers? Every time I set something down, I lose it. Is what it is, I suppose. But anyways, you can see, found them. Burn mark right here on the underside of this one. See if I can get it to focus. Turn on the light for a second. Right there. But anyways, that's an orange red. Tolerance band is gold. So this would be a 3,300 ohm resistor with a 5% tolerance. And this is a 222J capacitor, basically film cap. So you're looking at 2,200 picofarads or 2.2 nanofarad. J is going to be 5% tolerance, probably a 50 volt cap. Let's check the resistor first. And we got 3.286. I'll double check to make sure that that is within tolerance. switch this over to capacitance, and yeah, one lead on this is definitely blown out, so it's probably no good. We're probably going to need to replace this one. Yeah, we're getting 3 nanofarad. So like I said, 2.2, we're reading 3. Yeah, we will definitely be replacing that one. All right, so we can just use a simple tolerance calculator online for that resistor and that capacitor. Resistor is 3,300 ohms or 3.3K. Had a 5% tolerance. And what is our lower and upper limits? 31.35 and 34.65. And I believe we saw, what was it? It was 3,286, so that's well within tolerance. And then for the cap, it was 2,200 picofarad or 2.2 nanofarad. We'll just do 2,200 picofarad. Same tolerance, 5%. We were getting a reading of 3 nanofarad. And we can see that 3 would be 3,000 picofarad, so we're outside of tolerance on that. So it's going to have to get replaced. So what I went ahead and done is just go ahead and tallied up all of our electrolytics that we have. Didn't bother marking those, but including these on the board. See all of our ratings, so I can check my inventory for everything, see if I have enough to go ahead and cover this. I already know I don't have enough of these 2200 microfarad 16 volt caps, and I definitely don't have any of these. Again, I'm not sure if I got a way to, well, I mean, if I still have my octopus, my curve tracer, I believe I got it here somewhere. I might not have brought it with me. I could try to throw this up on a curve tracer and look at it. I'm not sure if my fluke meter will be able to, at 40 volts, be able to charge this enough for me to get a good reading or check the rated value, but I'll figure out something to do with those. These small caps I could definitely measure, and I get to determine if they're in and out of tolerance. Of course, you know, like I say in all my videos, I can do a lot of measurements on the board and have a good feeling for idea of how they should measure, but that comes with experience. The best way to take a measurement of a cap is to completely remove it from the chassis and then make a measurement. As far as our power transistors and alternating transistors and all that stuff goes, you know, they got their N and P junctions. So like this, what was that, MJE 15031 should be a PNP transistor, power transistor. So if I put it in diode mode, the base is going to be on the first. Of course, you can look this up yourself. First pin will be the base, and then the other 2 pins should read like a diode. So I think it goes base, emitter, collector, right across. Oh, I'm on the wrong thing. Let's go there. Yeah, base, emitter, collector. Yeah. And then, of course, base 2. If I can do this one-handed. Emitter. Anyways, that's good. And no short across the collector to emitter. Come on now. Anyways, no short across collector to emitter, so we are good there. But I'll go through and check all these, you know, when it comes to checking. You know, I've shown in the past that we can, if any of these are actually a voltage regulator, we use the oscope and inject a voltage and make sure that they regulate. So I'll come back to those. But a lot of stuff you could do with the DMM. Sometimes you need to do it with an oscope if you suspect bad. But like I said, he said that this was working, so I'm not overly concerned about any of our Darlington transistors or power transistors or voltage regulators or anything like that. I just want to give them a once over for my personal satisfaction, because if I work on something, I like to just, you know, take that extra time, especially if it's a customer related product. So I've tested what I can as far as transistors go. They all seem to be testing fine with a diode check on my multimeter. So before I start going through my entire inventory and seeing what capacitors I have that we could go ahead and start replacing, I want to fix the damage on this board. So I've got a couple 10 microfarad 50 volt caps, because I did check to see if I had a few of those. And yes, I know this resistor and this other capacitor belong here, but they are going to be placeholders for us right now as we attempt to repair this board right here. And I'll show you what we're going to do. Get a couple little strips of tape. What I'm going to do is I'm going to feed them, just the legs of them, through the board, and just kind of fold them over a bit. Same thing on this side. All I really need is for the legs to come through to the other side. Then we're just going to use some tape to hold those down in place so they don't fall out. Now I've flipped the board over, and you might be able to notice, although it's kind of hard, probably hard for you to tell. I'm gonna get these straightened out. I did not put this one lead through the bottom side of this trace in here. I actually lifted the trace a bit, because what I want to do is I want to keep this trace out of the way, and hopefully we don't break it. I'm going to keep that trace out of the way, and we're going to do some patchwork here. What I'm going to do is get some solder mask, and we're not going to use a lot of this, you know, just very small layer, because I want to provide a layer of insulation between the residue of the carbon that's built up on the underside of the board, and just get a small amount layered across this board, and these leads will keep the holes from being clogged up. And then once I have a nice layer on here, we'll dry it out, and then I'll take that that one lead that was lifted, and I'm just kind of painting this over this one trace right here that was lifted. After this has been dried and cured, I'll take these leads out from the capacitors, and I'll take the trace and lay it down, and we'll do then put the capacitors back in and do one more layer, if that makes sense at all. So this is going to be pretty boring, just me patching up this stuff quite a bit. I gotta leave this one open for now because we have to make a new trace or via here to that lead sitting right there. But yeah, this is boring, rather boring stuff, so I'm not going to record all this work. I think I've explained it as well as I need to. So I'll work on this for a while, and then I'll come back and show you the end result. So we've here's the end result. I put down a layer of conformal coating or UV mask at the bottom, and I pulled out these leads here and put this trace back down, fed the lead back through, did another layer of conformal coating here or UV mask, made a little jumper wire as you see right here. Of course this lead is not soldered to it yet, but put put a tad bit of UV mask formal coating on it and have let it cure for a bit. I'm actually going to just go ahead and leave this overnight since it's dinner time anyways, and I've worked on this long enough. Forgive my shaking, it's starting to get cold outside. I'm working in a shed. But we'll let this sit overnight, and then we can get back to working on this and start replacing capacitors and stuff. Well, we have sufficient drying time, and I'm back on this. The conformal coating or PCB mask or whatever should be good to go. Again, we let it cure. It's been a few days. I actually ordered up all the components that we need for this guy, and what I did is I bought in bulk these and all these. Now, I did have a few on hand, but not in the right quantity. So what I did is I bought a bulk purchase because I needed to refill my bench stock. And then, of course, the customer only gets charged the amount of what items are going in per what they cost and by amount. So take that for what it is. But anyways, I can pull out these old caps now, and we can get the replacement. We get the resistor back in here, and that replacement capacitor. Feed them both through. And there's really no good way to demonstrate because of how big this thing is. Soldering and removing of components and stuff. So what I'm going to try to do is because the board is just easier to prop up on its side, it's just not a good way to really do the filming of all this. So what I'm going to do is I'm going to try to demonstrate one per each section of the board, or the different caps and capacitors, and but I'll do most of it off camera so you're not sitting through a whole big old speeding up section. Now, one thing to note, I've put the resistor back in, but I went ahead and verified how's it registered on the board, and by registered, red, color coded, left to right, right to left. How are the other ones being registered on the board? So when I put this back in, I want to put it back in a way that is exactly the same as when it was originally made. So you should be able to see right here, hopefully, that we've got that we're registering our first two bands, orange, then red, and then tolerance gold, which is exactly the same way that you would read down here at the bottom with how this other one is situated on this board and oriented or registered. Okay, so we're going to keep it exactly like the way it was made. And to me, that's aesthetics. It's how it was manufactured. So I believe that is incredibly important to do. The other thing is well, I found a 22J capacitor, the rated value it should be. Okay, you see that right here. But it's not brown as what would have been original to this PCB. It's gonna be there, whatever. And I could find some Panasonic, so Panasonic made these. I could find replacements of these on eBay, okay? But then again, what's the risk there? Do I buy a bulk purchase off of eBay of some random person who has a bunch of these old Panasonic capacitors, and then have to test all of them and see which ones are in tolerance, which ones are out of tolerance before I use them, just to have something aesthetically pleasing in here? Could they potentially be fakes? Those are all the things that go through my head. Or do I just go with a reputable supplier and put it in the board despite the aesthetics? Well, you can see the decision I made right there. So I think it's better for the customer to use a reputable supplier of what is needed, even in some instances, even if it's not as aesthetically pleasing as the components that were originally in there. In all truthfulness, the way I was taught how to solder and how I was required to teach soldering in the advanced soldering course I used to teach for the military is when you feed your leads through, okay? You see how on this board they feed the leads through and then a machine probably just comes in and solders everything. This is most likely not soldered by hand. But the way I had to teach in the advanced soldering course is that you actually bend your leads over like you see here into the direction of your trace. And then you solder your leads in. So I did want to annotate that. And let me get my soldering iron turned on in position and I'll go over soldering these two components here. I'm only applying a little bit of flux just with the lead of one of these caps that I used to rebuild, repair this PCB. Now, solder goes where solder flows. I prefer to have a flat tip on this, but I can't seem to find it, so I'm just using this hook tip, which I traditionally would prefer to only use on IC chips, but we are going to put the tip on one side and then feed a bit of solder through on the other. Always keep your tip cleaned after use. And then secondly, I reapply a tad bit more solder. So that way while it's in its holder, the tip's not burning. It's got something that it can wear on, which also requires cleaning the tip and grabbing some more solder before you begin soldering again. I want to make sure that this lead, despite already being bent over, is slightly cleaned up because I do have this conformal coating over it, and that's going to be a barrier between that and the actual lead. So what I'm going to do is scrape away a bit, and then we should have an area in which we can solder to a little bit better. And we repeat the process. And that's come together nicely. Let me snip these leads away. And I'm going to quickly test each point. I do need to clean it up. I'm not going to demonstrate this lead right here because I need to push on the other side of the board and solder from the top to get the lead a little bit further down. That'll be a tad bit hard to hear. Or to video, excuse me. But as of right now, I'm just going to check for continuity. That's good. That's good. And then this, any of these over here. That's good. And nothing shorted together. Okay. For those of you who are interested in the part number, there it is right there. You can see I ordered off a Mauser. 2.2 nanofarad or 2200 picofarad, 0.0022 microfarad, 50 volt, 5% tolerance. So now I want to turn my attention to power supply section. So we're actually going to work from this end over here and then move down to recap the board. All these caps you see right here, you can see I put a red dot on them so I know which ones I've done once I start removing them. And these were the 2200 microfarad 16 volt caps. Now all the caps I selected are RoHS compliant and RoHS compliant where they need to be. And then for the ones that don't need to have that, I selected high temp or long life capacitors. So for the 16 volt 220 microfarad caps, we're using Nichicon capacitors rated for 16 volts, 220 or 2200 microfarad. And there goes that part number up here if you want to see it. Now, size-wise, these caps are nowhere as big as the old ones, but their temperature rating is just as good, if not the same. Let's see, up to 105 degrees Celsius. And these are going to last for a good long time. I think Rubicon made a similar cap, but I went with Nichicon because the customer did mention in some forums that Nichicons were used. And so he, and they're a good brand, so he trusts them. And realized I was kind of, yeah, you can see the size comparison there. Are used, and they are a good brand, so it doesn't have to be Rubicon. Nichicon can be used so long as you get it from a reputable supplier. Before soldering in the new caps, I look at the board and I think to myself, well, how hard would it be to do one at a time? And these are pretty close to together. It's not going to be easy to take out one and put one in, so we're going to remove all 12 of these first. In order to do that, let me reorient some things. Okay, you can see I've got the board positioned where it's hanging over my bench a bit. So all these caps can be pulled out. I've got room underneath it to pull with my hand. You know, make sure when you replace the caps, you're registering them back the same because they are polarized capacitors. I think it was lead tin solder that was previously, yep, it was used on here. But what I'm going to do is flood a little bit more solder into each one. This right here is going to act like a big heat sink for our positive rail. So I might have to turn the heat up a tad bit. Yeah, let me just go ahead and do that. I've got it set to, I had it on 650. We're going to set it to 730. Let's just see if that helps a tad bit. Now we're going to go through and do our best to get up as much as this solder as possible from the board. So we are going to actually, instead of wasting a lot of wick, I'm going to try to use my solder sucker. And we'll just come right in and, well, that one's wanting to be a tad bit difficult. So I'm going to come in with the wick now. I think for the most part we've got all that wicked up. Oops, I did not mean to do that. Let me see if I can snip the leg here. That one's up easy. We got a little bit of wiggling. Let's see if we can get this the rest of the way out. I think it's just this side now. Fortunately, the pad's coming up on this one. I see why you mentioned people said in the forums that these are notoriously difficult. So I'm going to get that pad up, and we can put the pad back down. That's not going to be an issue. They're just held in with a tad bit of glue. You can use a tad bit of super glue to get that pad down. You don't want to, however, on the positive rail, lift those pads because then you're damaging the rail. There we go. That's one cap out. A lot of fuss for one cap, and I'll have to repeat this process multiple times. No big deal. After playing around, it really only ended up being a temp issue, and you can see I've gotten that one glued back down in there. This side, the trace is just there to hold the lead in place, so it's not connected to anything else. But I turned up the temp to about 800 degrees. And all this is coming up a tad bit easier now, and we're able to get them out a lot easier. Again, I'll try to demonstrate. A little bit of flux on one side. We'll go to the negative pad, the negative rail. We'll go to the negative lead of the cap. Soak up all that old solder. Now onto the positive rail. This one's just a tad bit trickier. You can see that's kind of soldered itself, so we haven't quite heated up the board enough. A little bit of flux on this. Let's reattack it. You know, it would be better if I had a flat tip versus a hook one, but I can't seem to find it right now. I don't know where it's at. All right. I'm gonna use my snips to test to see if that's, yeah, see it's not soldered to the board. We're able to get this side up perfectly. There goes this side. Is the cap loose? Yeah, it's pretty loose. But instead, it's actually very loose. Instead of pulling it all the way through the board, I'm just going to snip off the ends because I don't want them to catch on anything and rip up a pad. And out. Simple as that. With it cleaned up, you can see now the damage or the etching that was occurring because these capacitors were leaking. You can see the difference in color from here, and then the discoloration more shiny here. That might be a good view right there too. You can definitely see the discoloration on our PCB here. So it's a good thing we got all these, we're getting all these removed. To repopulate our board, I'm going to orient our capacitors the correct way. And we do have positive indication, or a positive indicator on the board of how they should be oriented. And we're going to try to make this as pretty as possible with each one. This is probably boring, so I'm going to pause, get them all in, and then we'll start soldering. With them all in now, and roughly the same height, yeah, they're going to wiggle a little bit till we get them soldered in, but the leads are bent, so we've got a reference point of how they should sit. So now I need to flip this board over. And with the board flipped over, we can start to resolder. But let me just go ahead and tin my soldering iron, get that on here. And let's just test out one on a larger pad and see how it does. And that's worked pretty well, so we'll just finish all these out. Okay, so everything is soldered in and all of our termination points are nice and shiny. Let me flip it over. And now I can inspect my work from the top. And not too shabby. And this one's a little bit out, but they're all the same height, and it only takes a tad bit of pressure and we can line them all up and make it look nice and pretty. Well, I figured before removing one of these caps and recording it, I'd give a practice myself, and yeah, just like these, it's going to be temperatured. Temperature is going to be really important, especially to get out any lead that's on this ground plane. But we can see that there's a mistake was made. So in trying to save him the customer a bit of money, I selected up 50 volt 10,000 microfarad cap instead of a 40 volt DC 10,000 microfarad cap. And you can by all means run this cap in the application of this amplifier at a higher voltage. You could have higher voltage in here than what is being used. That's not an issue, as long as you're at or incredibly near, I mean well within like a 5% tolerance. Typically is what I would do if you wanted to go use a slightly higher microfarad rating. I wouldn't suggest it. I'd keep this exactly the same, but you could go slightly above the voltage. Well, these caps were like $4 and change versus these right here, which were over 10. But you can definitely see that there is a height difference, which is, before I ordered these, I told myself I probably should have measured the height. And yeah, these old caps are 36 millimeters in height, and this one's 50 millimeters. So I'm going to go back and measure the customer and say, hey, look, try to save you money on these. And he already knows this because I sent him the quote, told him what I selected and the reasons why I selected them. But I want to inform him that we will have to use one of the more expensive capacitors, and see if he is going to run this in the chassis with the cover on top or not. So that could be his choice. If he's not using the cover, then this is perfectly fine because this isn't going to hit anything. But if he is, it is way too high for this PCB, this amplifier board. Way too high in height. Okay, so I got in contact with the customer, and actually I was able to find some Nichicons at the right height that were a tad bit cheaper than the other ones I had bought that were too tall. So I'm gonna have to, like I mentioned, I'm gonna be eating those 4 other caps I bought, and because they're cheaper, I'll probably lose about roughly $32 on this overall repair. But I'm not passing that on to the customer. That was my mistake, and he'll get his quote is actually going to go down a few bucks compared to the original one. But since I don't have these yet, and they've got to arrive from DigiKey this time, we've done this section. We're moving on from this section until we can come back, and we'll start at some caps through this section in here. Now, as a short aside, when it came to replacing this capacitor right here, if you'll follow with me on that diagram, if you see it right here in the top corner, actually, let's see if I can bend this up. You see that 42 volt line? Well, if you were to, did I got this upside right? Oh, wrong side of the page. Yeah, here we go. You see up here in that top right corner there, that positive 42 volt line, and if you would follow it down, there goes C126. So we know that 42 volts is at least going to be applied to one side of this cap. So if you're struggling to find out what voltage rating you should use, I mean, typically you could double it. You could go with 100. 50 volts should be okay. So, but moving on from that, next we're going to replace all the 100 microfarad 25 volt caps, which have a 20% tolerance. So you can see the part number located there, and I'll demonstrate 1 or 2 of them. We've got several on the board, and you see they were a darker blue. We'll be going with a lighter blue. Tad bit different form factor, but it will be okay. It'll still pop. Actually, it'll probably mesh better with these caps right here, the color. I think the replacement ones actually are black, but we'll bring some of this blue back into here. But yeah, let me get set up and I'll show you how I will go about replacing one, and then I'll just go and replace all of them and we'll move on to the next capacitor. So replacing these is going to be rather simple. I've taken my soldering iron and turned it down from roughly 880, 900 degrees back down to 680 because we have smaller planes on these vias or traces, whatever you want to call them. I've went ahead and marked out 2 caps, as you see right there. They're leads, by looking from one side to the other and then marking with a Sharpie marker. So how I like to remove these is really just with some solder on the soldering tip of my soldering iron, like so. And then I get my hand on one side of the board, and what I'm going to do, since these are caps were put in with lead solder, so I just heat it up and then I pull them out just like that. Okay, now once they are out, then I'll come in with a bit of, actually I need to trim it. Where's my snip set? With a tad bit of copper braiding and a little bit of flux on it, and we're just going to come over the top and soak this stuff up just like so. And at this point we can clean our mess. A little bit of isopropyl alcohol and a Q-tip or cotton bud, whichever vernacular you want to use. And then I can flip this board over and we can get busy on installing the new ones. And pretty simple on this board. We have what is essentially the positive lead marked for each one. Negative lead is down on the bottom, so they're all oriented basically the same direction, except for a few cases your negative lead is oriented differently, but at least this PCB is marked. If yours isn't, you'd have to put a dot or something to indicate which was a positive lead and which was a negative prior to removing. Otherwise, you know, there's always that risk of forgetting which way it was oriented, and then when you first power up, running into issues. And I'm going to try to get these as flush as possible because the previous ones were very flush to the board. Now, I don't really like, I do like leaving an air gap when I'm working on electronics and capacitors. I think it's more appropriate to do that. But I am going to keep, with as much as possible, the aesthetics of how this amp was designed and manufactured for the sake of the customer and the sake of the you know, the general aesthetics of this amplifier to begin with. Alright, so I've got them both in the board and I've bent the legs over. I'm going to flip it back around, and I need to turn this leg that way. This one's good to remain there. I'm going to rotate this leg so that way it is in line with its trace. And that leg is good to stay there. And we're going to solder these back down. So I've got those two done. And then what we can do is we can take our multimeter. Again, what we're looking is for continuity between this trace and whatever else it's connected to. We got continuity, and we shouldn't have a short between each leg. Good. These are going to have to be checked on the other side. So let's snip off the remaining portion of our lead. Okay, on top, I can see that that via travels to this resistor here, or lead or trace. So I need to go on the bottom side, and then I can go to this side of that diode, and we'll just see if we have continuity. And we do. That's all good. And essentially all the capacitors on this side are going to be replaced the same way. Okay, so we have our 100 volt caps, and if they get a little bit out of whack, we can straighten them up. We have our 33 microfarad 16 volt caps. You can get the part number right off of here. We have our 10 microfarad 50 volt caps, and again, Mauser part number right there. And then I believe these were 10 microfarad 35 volt caps. You can see them there. And I'll get this entire section replaced. Well, finally gotten in the last caps that need to be replaced. Found the ones that I needed at DigiKey this time. You got that part information right there in the upper left hand corner. Here we go. As with everything concerning desoldering, solder flows or where solder goes. If you remember that, you'll do pretty well. So what I've done is I've got my soldering wick right here, just a little piece. Got my soldering temp up to about 870 because these are pretty big pads. I'm just gonna kind of pre-warm all these up with a little bit of solder on my soldering tip. You can see it melting right there. Put a touch more on my tip, and we're gonna come over and do the same thing over here. All right, then I'm gonna come down, and we're just going to hold this, and we should see this solder braid start to soak up all the solder down on this pad. And what was the through hole, basically where the termination points were coming through, the bulk of that is now out. I should be able to heat these up and wiggle the capacitor a bit. There we go. It is out. Now again, all these capacitors had a positive and negative polarity because they're electrolytics. So make sure that you're annotating where the positive was at on what side. This would be a positive pad. Actually, sorry. This would be our negative pad. The positive for C38 would be over here. So that means the positive for C327 is going to be upwards here. I'm just going to pop these in. Okay. Let's pop this one right here in as well. The teeth on them help grip, so shouldn't have any issues with turning the board over once they're in. And I'm not too concerned with cleaning these. I'll clean them after I've gotten them all replaced, but I'm just going to put a bit of solder on the tip. I'm going to hold it at the base of the cap or the lead, and then we're just going to feed in our lead tin alloy solder from that point. Now I'm going to remove these last two off camera, get them in, and then we will test out the device.
Ooh, looky there. There appears to be one capacitor I almost forgot. 10 microfarad 35 volt. Hidden, tucked away underneath this transformer we have here. So I have to get that replaced too. I definitely overlooked it when I was working on the rest of the board and counting how many electrolytics were on here.
As a quick aside, now we got these caps taken out. 10,000 microfarad caps, 20%, meaning 8,000 to 1,200. Let's do a quick check on them. So you can see that we're below the lower end of the tolerance on that one. Again, same with this one. And we're barely in there on this one. And again, barely in there on this one. So these big old filter capacitors definitely needed to come out of this device. Now, I know this looks like a bit of a nightmare of wires and stuff, but with everything put together, it's now time to power up this board, check each channel, inject an 80 hertz tone. I'm going to do it at 1 volt, and check channel A and channel B. So essentially what I'm doing here is I'm taking my power supply, I'm feeding 12 volts directly into where our battery voltage would be connected at these two terminals here. Because I don't have a secondary power supply, I'm using my arbitrary waveform generator to generate a DC voltage on channel 1. Now that's going to go ground to the same spot the ground is from the power supply, and to our REM or remote, which will trigger us on and off, right? So 12 volts is there, the amp should turn on. Secondary channel is set up for 80 hertz at 1 volt peak to peak. That's being fed into the left channel audio input, and then the oscilloscope channel 1 coming out, connected between this point here, left speaker ground, and then left speaker out. And we'll just see how the sine wave looks, and if it looks clean and everything, we should be good. Okay, so let's trigger the remote. We'll bring this voltage up. We should get an LED turn on over here. So what if I do this like this? I'm currently at 5 volts, 6, 7, 8, 9. LED starts to turn on. 10, 11, 12. It's on, and you can see that 80 hertz sine wave sitting right here, and about 68 volts peak to peak. Of course, if we adjust our gain and everything, go counterclockwise, it shrinks, and there would be clipping if we're all the way max. So we got probably a phase and then a gain. And if it's overdriven, it's always going to clip. So what I want to do is I want to set it to the max setting without clipping. Okay, what was that, 70.4? And with everything set up exactly the same, okay, I'm going to kill channel 1, or excuse me, kill channel 2, which killed our output, and channel 1, so the amp shuts off. And then I'm going to move over the audio portions, so to test the second channel. Alright, so channel 2, my SIG-gen was put over to the right channel speaker, and I had to resolder the center conductor because it was broke. So just went ahead and took care of that to get back on that RCA connector. And then oscilloscope, right channel ground, then right channel positive side right there on those two terminals. And all we should have to do is just turn it back on. It's coming back up, and we should get right channel audio. And I'm not seeing anything. Let me poke around a bit and see what's going on. So we need to determine what is going on with this other channel, okay? And I think the main indication to us is going to be the fact that these LEDs aren't turning on. So that's going to mean that we're missing a voltage rail, so to speak. Okay, so looking at the schematic, you can see that we developed basically 6 voltages here. Positive 42, and this should be the right channel. Yeah, this is going to be the right channel. I can see by the components. Yeah. Positive 42, positive 36, positive 15, negative 15, negative 36, negative 42. Basically what we have is a lot of rectification occurring after T2 at diodes 300, 301, 302, 303, 305, 304. And they're being used to basically build or rectify and create our various voltages, along with the voltage drop that we would get across diodes 306, Zener diodes 308, 325, op-amp 300, and diode 307. Okay, so we're developing multiple voltage rails. Well, we can check these. I should be able to get our plus 42 off the positive of C309, our negative 42 off the negative lead of C310. I'm writing this down. Should be able to get our 36 right off the fuses. We should be able to check there for 36, I believe. If not, we'll look at somewhere else. But I can at least check the fuses and see if we're going to see 36 volts there. So that's fuse F3 and fuse F4. And then our positive 15 rail and negative 15 rail at resistor R343 and R344. I'm going to try to do this as best as possible without bumping the board too much. I need to turn back on my power supply. It's up at 12 volts. Let's get the remote triggered. Okay. So let me first probe C309 positive lead. If I can get a good angle on this. Actually, positive lead I think goes to right here. What do we get? Yeah, so that's going to be our 42. Yes, I understand it's a bit low, but we have that. So it's safe to say that we would see something comparable over here on the left channel, and we do. So that's there. Now the negative lead of C310 I think that's going to be, we might not get that off of there, but let me check underneath. Okay, so that's going to come off of here, I think. Yep, and we got that. There goes our negative 42. And we would see something comparable over on this side as well. Now, at the fuse, we should see 36. We got a positive and a negative, but it's not 36. Obviously, it's going to be lower in circuit. I might need to remove the fuse to open it up to see if our actual short's there. But on the left channel, we have that. So let me turn this off and remove the fuses. All right, with those fuses now removed out of circuit, let's see what we got here. Showing 3. And negative 32. So we got an issue with our positive 36 volt rectification. And let me turn that off again. Get these fuses back in. We'll take a look at the 15 volt rail. Powered back up, we're looking at our 15 volt rails, which is going to be R343, and 343 should be our positive 15 volt rail. And 344 should be the negative 15. And for comparison, we can go to the other side of the board and check. Yeah. We see that voltage drop right there. 13 on both. The thing is I look at this, you know, let's say I remove 309 and test it in D306. If you're looking at the anode of 306, if the 42 volt rail was missing, 36 would be would go through D306, obviously drawing a current that might pop fuse 10A. But we're looking at the 36 volt rail being missing and the 15 volt rail right below it. Most likely 309 is good. I'll take it out and test it off the board because we just replaced it. And we'll check 306 out just to see what we're getting. Highly doubt we'll see 36 volts come back even with that. Still doubt I'll see 15 volts with that removed, because most likely this is all going to be common. Okay, so I ended up solving the issue. 100% this was a problem I created when replacing these 10,000 microfarad capacitors sitting here. As you recall me saying, make sure to check all your traces, lower and upper, because some of these are through hole, right? To ensure that there's still continuity. Well, it's hard to do it with these sitting on the board as far as they are. And 100%, when these snap capacitors are taken out, you gotta be very careful not to lift the traces that go through the board and connect to the other side, which is essentially what I did. So my apologies to the individual who sent this to me. I'll end up emailing him and owning up to that mistake. But what I essentially did is I back out those capacitors, and I ran a small wire from one side of the board to the other side of the board down each leg of the capacitor and soldered the wire in and then the capacitor in on both, and that resolved our issue. And I did read an article about these snap-in capacitors prior to work on it, and I did read that they are pretty terrible to replace for the very same reason. So whole lot of troubleshooting and waste of time, all because of a silly mistake that I made. But that being said, we've confirmed that componently everything on the power supply is good. So let's go ahead and power this up. All right, 1 volt peak to peak, 80 hertz signal feeding into the left channel input, measuring the left channel output. and I'm seeing 53 volts peak to peak and 80 hertz. Pretty clean signal on there. So without touching anything, I'm going to move channels to the other side. And now checking the right channel input. No change over here. We're getting like 51, 50, 51. You know, not exact same peak to peak voltage, but it's definitely, I believe, within the margin of error. So that's looking pretty good. And that's a pretty clean signal. So what I'm going to do now is I am going to switch to bridge mode. Okay, and that's obviously going to kill the signal because now both channels should be operated with an input on the left channel only. And with our input signal now rehooked back up to the left channel input, we are still getting the same signal on our right channel speaker, ground, and positive. And if I move this over to the left speaker, or slightly clipped, I'll back it off a smidge, but yeah, roughly the same. Looks like the left side amplifies just slightly more. So what I've done is I've went ahead and just taken out the other 10,000 microfarad snap-in caps and did the same thing on them, even though they were fine, just for surety, so that way there won't be any issues with them. I need to get all this board cleaned up and then and tested, but you know, we're just about done. And there we have it in all its glory. I've gone through and I've cleaned up the board. I did a bit of touching up where there was etching from electrolytic with a gold Sharpie marker to kind of blend those spots back in. What it etched to gold plating off of the top of the board in various places. Is it a perfect match? No, but still less of an eyesore when you are seeing gold and then you're seeing white spots in it. But went through and cleaned all this up with some isopropyl alcohol, tidied up the bottom, and it's you know, all back together. And I ended up testing it one more time, and both channels are good. Which, by the way, you know, 3 volt difference. What we were measuring, that's like what 0.6, a bit over 0.6 dB loss. So not even a full dB of loss between your left and right channel, which I think is you know, remarkable given the age of this equipment. And all that really means is that a little less amplification on one side, either because of you know, our driver amplifiers and that just that section down there, just components being a tad bit older, or maybe just slightly different values of you know, our resistors on the board. Maybe some have gone up in value over time, but really nothing too concerning. I'd only be concerned if I saw a dirty waveform at the end, and if there was a significant loss of 3 dB or more, you know, something along those range. You know, if you're getting over a dB, 2 dB, I think you need to start checking out some things. But the signal was clean and, you know, wasn't very significant. So all that's left really to do is just you know, package this up and send it back to hopefully a very happy customer, having a fully recapped amp, and you know, it being very uniformed and pristine looking. Should operate for him for quite a bit longer. And overall, I'm pretty happy with this. We repaired the broken trace on the left channel and it's functional. Recapped the entire board, and minus my one mistake with these snap-in caps there, which I'm pretty sure I made a warning about that at the beginning of the video. Because you can test continuity from leads to points on the board, but until you remove them, you can't test the continuity through the board. Say that eyelet sits in there, okay, like a tunnel, okay, and the capacitor sits down through the tunnel. There should be continuity through that tunnel as well, and there wasn't. So just one little silly mistake, which I'll leave in this video because you know, that will serve to help somebody else in the future if they're in the middle of working on the same amplifier and going through and doing a recap thereof. Anyways, I'm going to get this packaged up, invoice the customer, and mail it back to them. If you've stayed this long to watch this video, thank you for watching. If you're new to this channel, please consider subscribing. Give me a thumbs up if you like this video. Leave me comments. I do enjoy reading them. Try to respond when I can. That being said, everybody take care and goodbye.
Bark?